Hello students, in this video we will discuss p orbital shape and radial probability distribution curves. P orbital L value equal to 1. That is azimuthal quantum number is 1. Magnetic quantum number m is equal to -1, 0, +1. The number of suborbitals in p orbital. Number of suborbitals in p orbital equal to 3. So the formula is 2L plus 1, L is equal to 1, 2 into 1 plus 1, 3 suborbitals. Maximum number of electrons in p orbital. P orbitals 6 electrons. Maximum number of electrons in p orbital, only one orbital. P orbital equal to 2. P orbital contain 3 suborbitals. Each orbital have to accommodate only 2 electrons. The total p orbital contains 6 electrons. Each orbital contains 2 electrons. The p orbital maximum electron density is concentrated along the axis. Px orbital electron density is concentrated in the x-axis. Py orbital electron density is concentrated y-axis. And the pz orbital, the electron density is concentrated on the z-axis. P orbital shape is dumbbell shape. Dumbbell shape. A dumbbell shape is like this. It has 2 lobes. Px orbital shape this is the x-axis, y-axis, and this axis is the z-axis. In this axis, the electron density is the maximum. So whatever the plane is there here, that plane is a nodal plane. In this axis, in this plane, the electron probability value is 0. This plane is called as a nodal plane. For the p orbital, one nodal plane is present. Py orbital, the electron density is concentrated along the y-axis. This axis is considered as a y-axis, x-axis, and y-axis, z-axis. The electron density is present in the y-axis. In this plane, the electron probability value is 0. This plane is a nodal plane. XZ plane is a nodal plane. Here the YZ plane is a nodal plane. Next, PZ orbital. In PZ orbital, the electron density is concentrated in the z-axis. Z x, and this axis is the y-axis. In this axis, the electron probability value is the maximum. In xy plane, the electron probability value is the 0. So this plane is nodal plane. For px orbital, yz plane is a nodal plane. Py orbital, xz plane is a nodal plane. But pz orbital, xy plane is a nodal plane. Plane is nodal plane. Radial probability distribution curve for 2p orbital and 3p orbital. Radial probability distribution curve. Distribution curve for 2p orbital and 3p orbital. The first one is the 2p orbital. X-axis, I have to take the density, radius. In this axis, d function. Radial probability distribution 4 pi r square dr size. Dr size square value. You are getting like this curve. In this position, the electron probability maximum is present. The distance is 2.1 angstrom units. For 3p orbital, that gives the two curves, d function, a radius. This is for 2p orbital. Number of peaks is equal to L value. Number of peaks is equal to n minus L. N is 2. L value is equal to 1. 1. This is for 2p orbital. For 3p orbitals, number of peaks is equal to n minus L, 3 minus 1, 2 peaks. So this is the first peak and second peak. Number of spherical nodes. Number of spherical nodes is equal to n minus L minus 1. For 2p orbital, n value is 2, L value is 1 minus 1. 0. So there is no nodal region or nodal space radial node for 2p orbital. For 3p orbital, the nodal region 3 minus L value is 1 minus 1. One nodal region is present. So this is the one nodal region. Thank you. For more updates, please subscribe my channel.